to work on? We have to work on this integral, right?
Yeah.
Looks messy, doesn't it? And then substitution brings it under easy control, because notice this. Look at this guy here. What is the derivative of this? Okay, tell me that. So very good. Just so I'm looking at the derivative of this, right? Or differential of this, in other words, right? So who will be the differential then? E to the x for this, right? Then you use the chain rule, and what do you get for this?
Negative
E
to the
negative x, right?
Yeah.
Makes sense? Dx, right?
Yeah.
Okay. So the differential of this quantity is this, right? Isn't it? So if, say, we did this right here, say took this as u, okay? Not this, rather this, okay? Then what does it mean? That this quantity, this expression here is what? Du, isn't it? Look, right? So this whole thing changes into something pretty simple. And what is that? What is that? The du over, say that again.
Du over du.
This is not du, this is what? See, this part is du, of course, right? And this is stays, okay, just a moment. See this thing here? Okay, if you wanted, I could just rearrange it like this. See here, right? Dx. Making sense? Right?
Okay.
Okay, then what is it? Tell me.
Okay, so it's du over u.
And who is that when I integrate? Who is the antiderivative of 1 over u? Ln of u, right? And he, it's ln of absolute value of u, but the thing is this quantity can't be negative, right? So we can just write ln of u, right? Looks good?
Yeah.
Okay, don't be disappointed. Let's do another one.
No, when I'm telling you, it seems so simple.
It will be simple, I guarantee. Don't worry about it here. So let me just ask you to do something, okay? We'll pause the, oops, sorry about that. Why is it? Just a second. Ln x, right? Okay. Why don't you do this? And let's pause the camera for some time. So now, first we tried x to the -1 and didn't work, right? Because we have to inspect when you are using the substitution rule. Typically what you want is you want to see if in your entire expression, part of it, which can be factored, okay, is derivative of another part, right? Okay, so you did this very well. That was very nice, the way you did it, that you took natural log of x, then split it as a factor like this, but then we tried substituting this as u, and that didn't do much for us, right? Makes sense? Why? So notice this. This 1 over x is the derivative of who? Natural log of x. So who is the candidate for substitution here then? Very good. So if I have u as ln of x, what is that going to give to me? Du equals 1 over x, then dx, right? Makes sense? Okay, so this whole thing becomes what? This becomes, yeah, go ahead, sir. U, u, u du, right? Yeah, very good. And then you have what? u square over 2 plus what, a constant, right? And then if you want, I mean actually we should just write, okay, is that coming back well now from right? Okay, now you know what a good strategy would be. Let's go to the use of integral test in that infinite series question that you were trying to do. Okay, all right, so let's go straight there now. All right, okay, so what we got here, so first tell me this here, that is, I mean, of course we don't see the antiderivative of this being directly available, right? Okay, so what we will do then is this, we'll think of substitution, right? Okay, now if I took derivative of cosine x, what will I get? Negative sine x. I don't see that anywhere, do I? If I took the derivative of this, what would I get? Very good, and cosine x is sitting right here for us, right? Very nice. So let's just try this out, right? So as you said, it's negative 2 cosine of x dx, right? And then we got a du, right? And then what happens is this, we get cosine x dx equals what? Negative 1/2 du. Are we good?
Why 1/2?
2. I brought it over here. Okay. So now you were talking about the limits, right? So here we can change it right here. I mean, you can do it either ways, either like, you know, write the integral back and put them back in again, or change them right here. In this situation, we can do that. So see, when x is 0, u, that is this whole thing, right? Okay, this is sine of 0. How much is sine of 0? 0. So u is going to be how much then? Simply 1. Because very good. Very nice. Now when x is, what was the upper portion? Oops. Pi over 2, right? Then we get u equals what? All that applying on who? Pi over 2, right, sir? How much is sine of pi over 2? 1. Very nice. So u becomes how much then? No, 1 plus 2 is
1 times 2 plus 1, 3.
3, right? So u is 3. I mean, that's what you meant to say. Okay, good, very good. So let's go here. So our limit transforms from 1 to 3, right? This guy cosine x dx becomes what? Negative, right? Right, negative 1/2, correctly said, right? And that's a, oops, sorry, that's a u, right? Are we good? So that is negative, let's pull 1/2, where? Outside, right? And then we go, this is out, right? Negative, and then what? 1/2, and who is this integral then? Ln of what? Du, antiderivative of 1 over u is ln of u, right? Makes sense? And this is going to be taken from where to where? Just do 1 second. Okay. So we get right here, top is how much? 3, and the bottom is 1, right? So that's negative 1/2, right? Ln of 3 minus ln of who? 1, right? ln of 1 is 0, isn't it? So let's see what it comes out to be. Just do. Okay, now we have a negative answer, so we have to see if we made any mistake, right? And we did make a mistake. I don't know where this negative sign came from, right? Notice that, right?
Okay.
So this doesn't, we don't have to have this here, right? We don't have to have this here. So it's always good. I mean, say if you can't have definite integral, always graph and see if we have the area over or under, right? Now we are good, right? Are we good now? Makes sense? Okay, so let's go to infinite series now because we're getting close to 2 o'clock and then I have a meeting then. Okay.